Hi math lovers, welcome to notes number 31. Today we're going to study other types of inequalities, lesson 1.8 from your textbook. Before we get started, I want you to think about a times b is greater than 0. If you know a times b is greater than 0, what has to be true? Well, you know that this would have to be positive, correct? So to get a positive, then a and b have to be either a positive times a positive, or it could be a negative times a negative, right? So we could say simply the same sign. They would have to have the same sign. Makes sense. We agree with that. If a times b is less than 0, all right, so to get a negative over here, a would have to be negative and b would be positive, so a negative times a positive, or I could have, how about a positive times a negative? So I would say different signs. Okay. So that's going to help us with our lesson today. We're going to be thinking about the signs that we're going to use in our inequalities. Notice that all three of these problems are inequalities and they have quadratics, or this has a power of 3. Ooh, a cube. All right, so let's go ahead and work with these. I'm going to jump in here. If this were an equal sign, so if underneath here were an equal sign, what would I do? Well, I'd move the 6, right? And I'd factor. So let's go ahead and do the same thing. X squared plus x minus 6, and instead of an equal, so I'm going to put a greater than 0. All right, so if it's greater than 0, I'm gonna think about factoring because I love to factor. Be x plus 3 times the quantity x minus 2 is greater than 0. Now, do you see the tie-in that I have up here with the a and b? So it would work if this term is positive and this term is positive, or this term is negative and this term is negative. Now, Ron does a really nice job in your textbook of explaining. Oops, I just lost the focus there. Hold on just a second. There we go. Ron does a really nice job in your textbook of explaining the OR method and uses core points and important points. But that's great. I didn't learn it that way. I learned it with number lines. I'm a visual learner, so let me show you how I'd go ahead and do it. So I think about my two factors that I have here, x minus 2 and x plus 3, and I make a little number line for each one. And then finally, I'm going to make a product for both of those, a number line for the product. Now, if you're messy like me, you have to try really hard to be neat, okay, because this is going to be so easy, and neatness is important here. So if I have x plus 3, what is going to make x plus 3, the factor of x plus 3, positive or negative? So let's start with 0. What would make x plus 3 equal 0? Right, negative 3. So I put a 0 here. If I put 0 in, it's positive. If I put, say, 2 in, it would be positive. So all these values to the right would be positive, and to the left would be negative. Let's do the same thing for x minus 2. What would make x minus 2 equal 0? 2. So I'll put a 0 here. The numbers to the right, 7, 10, 100, would make it all positive, and to the left would be negative. All right, so what you're going to do, kids, is you're going to drop your important points here. So I'm going to go ahead, I'm going to drop this negative 3 down. I'm going to drop this 2 down, and I've broken my graph, notice, into 3 different parts. If I were to multiply a negative times a negative, I get a positive. I multiply a positive times a negative, I get a negative. A positive times a positive is a positive. Okay, now go back to what we're looking for. We want to know when this product is greater than 0. So I want to shade the part of the graph where we have positive signs. Am I or equal to? Nope. So I'm going to use open points, and I would shade the part of the graph right here, and I'd shade the part of the graph right here. Okay, cool beans. All right, so there's my answer. If I put any of the values in on that shaded region into my problem, I would get a good solution. All right, so let's look at number 2. Here I am in number 2. Right away, I'm thinking of factoring. GCF, y times the quantity, y minus 3, is less than or equal to 0. And I have 2 factors. So real quick, I'm going to draw 2 number lines. Again, being real neat. All right, and then the product, y minus 3. Okay, great. All right, put 0 in. Always anchor yourself with 0. All right, so think about the factor of y. What would make the factor of y equal to 0? Well, 0. And all the values to the right would be positive, and all the values to the left would be negative. How about y minus 3? What would make that equal to 0? Positive 3. All the values to the right would be positive. All the values to the left would be negative. So I'm going to go ahead and I'm going to drop that 3 down. Drop that 0 down. Here they are right there. Now go ahead and multiply. Negative times a negative is a positive. Positive times a negative is a negative. Positive times a positive is a positive. It's just coincidence that it looks like the last one. It's just coincidence. So think about where I want to shade. Okay, I want it to be less than or equal to 0. So less than or equal to 0 would be this negative section, and or equal to, so I'm going to shade these two coordinates in right between them. Okay, you should probably put their variable y there because you know you're going to use your variable y. That's what you're talking about. And then we've gotten to number 3. Okay, I'm excited to factor this one right away. I'm thinking GCF, aren't you? Whew. Jumping right in, cannot stop me. Okay, so here we are. Hey, I can factor that again, can I? I'll factor it again. I was thinking about something else, but let's factor this again because we're on day 1 of this. All right, I've got 3 factors, 3 number lines. Okay, I know some kids don't like to do this because it does take a little bit of time, but I find after all my years of teaching that kids do not make mistakes when they go ahead and they draw it all out. Okay, what would make this 0? 0. Numbers to the right are positive. Numbers to the left, if I put in for y, are negative. Here, this would be 4. Positive to the right, negative to the left. This would be negative 4. Positive to the right. So far, we haven't done anything difficult, have we? I mean, it's just a matter of keeping this neat. Negative 4, 0, and 4. I'm going to go ahead and break my graph into all of the different sections, keeping it nice and neat. Okay, here we go. Now, negative times a negative times a negative is negative. Negative times a positive is positive. Positive times negative times positive is negative. Positive times positive times positive is positive. All right, so ready to go for that final answer here. I've got my key points of negative 4, 0, and 4. I want this section, I want this to be greater than 0, so I'm only looking at part of the graph where it's positive. So that's between negative 4 and 0, and greater than 4. Oh, look at that. Beautiful. All right, and it's or equal to, so I can use my solid points. Okay? So, nice and fun. Again, Ron has a different method in the textbook. His method uses key points. Take a look at the way Ron explains it. I find that over the years, the kids do not make mistakes when they draw the number lines, and you're looking at each factor individually and thinking about what make that factor positive, what would make that factor negative. Have fun, kids.